Today what we're going to go through is session 1167. What we called this was architecting for vCloud allocation models. It's kind of a broad topic, but we're going to walk through a couple of things that hopefully will help everybody understand how allocation models work, where they drive down into vSphere, and give you a little bit more understanding. So disclaimer, we'll skip that. Quick introductions, and then Rawlinson's going to do some of the introduction stuff. So my name is Colotti. I'm a consulting architect with what's known as the Global Center of Excellence inside VMware. VCDX number 37. You can follow me on my blog and my Twitter, which is up there. We can always use more. We can both use more followers, actually.
Sure. My name is Rawlinson Rivera. I'm a senior consultant in the cloud and infrastructure management practice in PSO. I'm VCDX number 86. You can follow me at my Twitter handle at punchingclouds.com. I'm always knocking clouds out of the air, so I'll let you know. So the agenda here, we're going to talk about a couple of things we want to introduce in the purpose. And obviously, one of the biggest focus that we have now when it comes to cloud is how we are going to create these what so-called service models. You know, what makes up these service models? Because it's what you're going to end up doing, basically, what you're going to end up offering within your environment. So there's a couple of things that we're going to get into. We're going to try and correlate what you see in this cloud and this abstraction that is provided by vCloud Director to the vSphere infrastructure, so that you can kind of make a connection and understand what happens underneath, right? And there's a couple of things that Chris and I talked about yesterday. He came up with something completely new because it happens, which is going to be a clear example of how dynamic this sort of thing is. And we'll be able to probably talk about that and present that to you guys. So we're going to get into an allocation model deep dive where we talk about virtual data center review. We're going to get into what happens in there, what happens when you define these service levels and how it affects your offerings. But also, I'm going to assume that everyone that's here has or is familiar with the vSphere platform, the core. Raise your hand, let me see. Everyone, right? How many of you have Cloud Director in a production environment? Awesome. Dev environment? Even better. So we're going to get into some topics where we actually want to make sure that everyone is aware of what happens underneath as these allocation models and the service levels that are defined tie into your vSphere offerings and how that affects your planning and you're doing in your architecture. We're also going to get into a very, very, very important topic, which Chris will dive into pretty deeply and explain the risks that exist when you don't do proper planning and you don't consider some of the things that we will tell you about in relation to HA. So there's a lot of things that we have to take into consideration before we kind of start planning these things on the fly. And if you don't have a pretty good understanding of what's underneath and what's above, it can be somewhat problematic in some cases. So we'll get into a couple of real-world use cases, things we've gathered from the field. Chris is in the COE. These guys obviously work on the alpha IP. You know, they get things moving. We come from the field. We deliver what the customers are somewhat doing. So there's some really good use cases that we'll get into there. So kind of talk about that, and then we'll present some options, some test cases. But just make sure that you keep in mind what we're discussing in this session. This is not a best practice. This is not a do as we're telling you.
That's our own disclaimer, right?
Right.
Some of the things we're going to throw at you, this isn't documented as a VMware best practice. Right. This is stuff that we've uncovered and have found that it's really useful to present to people. So it's just to get your thinking. Really. Yeah, that's the whole thing of this, right? Keep your minds open and kind of be able to adapt to the change that's coming for what you want to do. So on that segue there, so when we talk about what we're trying to do here, basically we always say, we started yesterday with the session, we said, open your minds, and obviously, we say, what do we have here? So things change constantly, things are very different, and why this topic is important. So when you think about architecting for, allocation pools or cloud, you have, obviously you understand what the goal is here. You have X amount of resources that have to be consumed by X amount of workloads. In what way, in what shape or form. There are pros and cons to everything that we do regardless of what you pick. So you have to be able to identify and choose whichever one suits your environment the best, suits your service level offerings, or whatever it is that you're going to offer in that case. What we're setting out to prove again is in order to be able to become adaptable, and so that you can grow your environments with, with the easiest or the simplest way of introducing changes to it. The key here is to remain flexible, right? So we're going to look into some of the things that we do. We actually provide currently now a guide on how do we help you kind of architect around some of these components. We make some recommendations, which in this documentation, which I'm referring to the VCAT, you'll find that we somewhat endorse, and we can say that we endorse some best practices in there.
Yeah, that's definitely a best practice document.
Right, so it's kind of like how you, and we do it on multiple levels, how to consume things, how to cover this particular topic as well. And for those of you that are not aware of this, we have a new version of the VCAT, which will be released fairly soon to match the new product that you guys heard of on Monday that was released. And there's a lot of new things in there to make your process of designing and configuring your environments, a lot easier. So it gives you an idea, right? Remember, not everything's static and it's not the same, so at least it gives you guidance on how you can now open your mind and start thinking about how to proceed in some of those scenarios. You're going to come across some terminologies that we're going to try to, for lack of a better term, simplify, right? So you'll find that there are terms that are called or addressed as some type of name and component within the vSphere infrastructure, but then if you look at the UI of the vCloud director, it's something that means possibly something completely different, right? So we're going to kind of put those things, you'll see Chris is...
We'll actually show you an example of that.
We're showing an example of that because it's somewhat confusing, right? Which is what the part is. I mean, for us to be able to understand what's really happening with vCloud Director and all that, it's an abstraction, right, of what you have in the vSphere core environment, right, in that platform. So we want to kind of make sure that we correlate those components there. Make sure that you tweet this, session if you like it. Obviously, you will like it, please. And do the hashtag and kind of follow and let us know what you thought about the session, how we can improve it for future purposes. So I'm going to let Chris kind of get into the definition of the service models, and we'll be jumping back and forth throughout the session.
So when I talk to people about defining a service level, one of the things you saw on one of the earlier slides is we consider this multidimensional, right? I talk to people all the time, and we're going to talk this afternoon in a group discussion about this as well, where everybody says, well, how do I define my service level? Well, this is where the traditional, everybody knows or works for VMware, the first thing you do when you get hired is you have to learn the word depends, right? Everything depends. So in this situation, though, it's really true because we don't know what our consumers are going to want to use, right? We don't know how they're going to want to use their resources that we give them as a provider. So we don't really have a way to define a set level of service necessarily until we talk to our customers, right? One of the other sessions we did, the very first bullet was you got to talk to people, right? You have to talk to your customers to understand how they're going to use the services you give them so you can give them the right level of service.
You don't want to assume, because if you assume, you look like you know what. Right?
Exactly. So what we're going to do is we always have anybody who's ever dealt with vCloud Director, how many times do we use gold, silver, bronze, right? You see that everywhere. These precious metals, right? So what Rawlinson's going to take you through, this is where our theory comes in. We kind of sat down and we said, all right, if somebody wanted to know what does gold mean, what does silver mean, what does bronze mean, we actually threw some examples down. We said, well, this is one way you could do it. And after a conversation with a customer yesterday, there was a fourth one that came up that we'll talk about. Really what differentiates each level, there's a service level at the provider, there's a service level at the organization, there's service levels everywhere within vCloud Director. So there's really not one service level. It's a combination of different service levels that make up the one agreement. And we'll talk through some examples of hardware and resources and usage. In the new bullet up there, one that came up was licensing. And I'll explain why when we get to that slide. I always get asked, is availability a service? Do consumers assume certain levels of availability? Do they assume that some things will be up? Do they assume that everything's replicated? Is replication a service? Is DR a service? Right? So are we providing that as a service, and does that in turn make it part of the service level agreement? Right? Maybe it is. So I actually went to the internet and I asked the Google, what is a service level? Because I figured, what the heck? So this is what came back. It came back as referring to contracted delivery times or performance, which I thought was interesting. There wasn't an and performance. And I highlighted that for a reason because these three things at the top, availability, they all relate to either availability or DR, right? Mean time to recovery, mean time to repair. Those are the things we traditionally think of as a service level. But then I said, well, why not performance? And I started talking to a couple of service providers, and I said, would you ever write a guarantee of performance? And they said, well, how would I measure it? And I said, I don't know. That's why I'm asking you. What would you measure it on? Would we measure it on transactions per second to a customer's database? Do we measure it on how fast our web page came up? But where were they at the time? Were they in the UK? Were they at my house in the woods in New Hampshire with a really slow DSL line? Right? I mean, how do you actually have a service? If you have a service level, you have to be able to report on that. You have to be able to show that you're meeting your service level agreement. So performance is almost, in a lot of ways, left out. We'll explain how it can be brought back in when we get through some of this. And that's really the biggest problem, is how do we monitor and prove it? And this last bullet is interesting. It's, as we go through this, there's a real big difference between the level of service and the agreement, right? So what are we offering as the levels of service to our consumers, and what are we actually agreeing to? Sometimes there's a disconnect. And I said this earlier, but when we start to look at this, you'll start to see that this is like a cube. We have to turn this thing and see different faces of it to understand what we're offering to our customers from a service perspective. It's not simply, here's your resources, go off and prosper and have fun and call me when something breaks. So what Rawlinson's going to do is we'll go through a couple of slides on this gold, silver, bronze idea, and then when he hits the last one, I'll talk about the one that came up with the customer yesterday, actually, as a matter of fact.
One thing I kind of want to point out, which is I think it's key, and it was back here on Chris's last slide. So how many of you here are service providers? So is DR part of your offering when it comes to cloud? Right? At what level? Infrastructure, the workloads of customer? Right?
Even that one question has connotations, right? Where's the DR live?
Where should DR, right? That's, where do you draw the line there? Now, the reason why I say that is because as of today, right now, currently, I don't know if everyone's aware, we have some challenges to properly say that. Well, we cannot integrate our DR solution with vCloud Direct. It's a work in progress, trust me. And the reason I want to come back here is because, as Chris said, keep your mind open, be flexible. How many of you are aware that there is a white paper that talks about the recoverability of vCloud Director using SRM? So cool. For those of you that didn't know...
Some people actually read my white paper.
Right, good. So for those of you that didn't know, Chris and Duncan wrote a white paper on how to do that, on how to achieve that from an infrastructure perspective. Thinking completely out of the box, using things, putting it together as VMware continues to work towards combining those two things as a complete solution. I was part of a customer engagement where I was kind of placed in a similar scenario where I had to come up with something to make a recoverability make a solution for recoverability of workloads within the cloud. When you look at what you have, depending on the environment, and when you start thinking outside of the box and you're flexible, you may be able to identify how you can achieve certain things that are not 100% built into the tools, right? So the reason I wanted to point that out is because there is possibility to do things. Obviously, it may require a little bit more effort. It will expose other things that you have to consider. But then it comes back to the whole thing about talk to your customers. What are you trying to solve? What are you trying to achieve? And you can identify the level of effort that it will take to do something like that, supportability and all that stuff. But being aware of it is really important. So I just kind of wanted to make sure that everyone knew about that because only a very few of you knew about it. And it's, obviously, DR is a big thing. And if you have concerns about that, where are we with that currently? This is a guy who actually wrote a paper on that already. All right, so let's get into the precious metal conversation. How many of you that are in the service level, the service providers, identify or qualify your service levels as what you see here, as silver, gold, bronze, whatever, right? Okay, not many. Great, but still, what happens, this becomes a common thing, right? We start calling these precious metals.
High, medium, low is another
medium,
one, right?
low, but good point, right? One thing what I wanted to kind of communicate is the fact is you don't have to go by these precious metals. It's obviously based on what's relevant to your business and what you have within your organizations and what you're trying to achieve. It doesn't matter if you call it white, green, yellow, blue, who cares, right? As long as it's relevant to what you're trying to do, it's how that's matched. Now, what's important and what makes these service levels, what makes them what they are? That category. Well, that's defined further down low about what you make part of that offering. In this case, when we talk about the bronze being, in this case, the lowest, it may not be the lowest in some of your situations, but in our example here, it's the lowest. And we say, okay, so the bronze offering is going to be composed of low memory, cheap SATA storage, not necessarily whatever, right? That's just our own opinion in this case. 1 to 2 CPU physical hosts, small clusters, fast provisioning enabled, right? Small VMs can get up to about 8 gigs in one virtual CPU, and the model for this may be pay as you go. When we talk about allocation models, everyone here is aware of the 3 allocation models we have with vCloud, right? Pay as you go.
If not, we're going to go through
If not, we're going to go through it, right? Perfect. Yeah, good. Thanks. So this is one of them, right? So why would that fit that model there? It depends. You see that your workload types are not big. You're going to be able to control what you have in that environment. That's what you're going to provide as an offering, but it could depend on, it could be whether it's a capacity deal, it could be a performance requirement, right? So you'll derive to these sort of solutions whenever you have these sort of requirements that you have to adhere to, right? So that's how you kind of start coming up with these things, and they can be whatever you want. They don't have to be these metals that we have in place. When it comes to silver, obviously we're talking about stepping it up a notch. In your environment, this is basically a tier sort of approach to what your resources, what you have out there. Here, obviously, things get a little better. We may have medium memory per host, fiber channel storage, mid-cluster sizes. What is the definition for mid-cluster size? You tell me. It depends on what you're going to put in place and what you have and how it compares to the others. In terms of the CPU, 2 to 4 physical hosts, whether you want fast provisioning or not, is that a requirement as part of your offering? Do you want to be able to rapidly deploy these environments and these vApps as you need to? That's another offering. In terms of the virtual machines, the workloads are going to come down to be medium workloads. They could be categorized here as 16 gigs of RAM, 2 virtual CPUs. Maybe in this case, what you're looking for is a mixed model, right? We're going to get into this as of why would this fit that model or not. And we're going to give you some input on that. Gold being the superior offering. Obviously, here's where you have the kitchen sink and everything that you own in that offering. I'm going to give you my Mercedes or Ferrari, whatever you want it to be. In this case, the memory could be exponentially, doesn't have to have a limit. Medium to large clusters, 16 and beyond, right? We have a max of 32 clusters depending on what you're doing. Fiber channel storage, maybe in this case you want to use SSDs. In terms of memory, 24. The whole point is you guys get the point, right? The more you offer, the better the offering. But in this case, we're talking about, hey, do I have a disaster recovery option? And like what we try to communicate before, where do we draw that line? Am I talking about the infrastructure? Am I talking about what your workloads are? Right. So that's where you have to define that, so that you can have a well-defined understanding on how to achieve that.
And when you talk to your customers, some things don't make sense, right? Some are going to require bronze level services and DR. Would that even be logical? Maybe, maybe not. One of the new ones that came up, if you can go back to the other slide. So yesterday, 2 new ideas came up out of some conversations, which got me thinking, which was licensing-based providers, right? A provider VDC, for example, in vCloud Director, that's a purpose-built cluster, and we'll talk about mappings, but the cluster is purpose-built specifically for, say, Oracle database licensing, right? And that is presented into vCloud Director as a provider VDC specifically for that purpose. Another one that came up was a high-performance computing, not high-performance computing, but a vFabric cluster, right? I was talking to Ahmad, another guy on our team, and he does tuning of hosts specifically to run SQL Fire and Gemfire. But once he tunes the host, the host tuning is done in advanced settings in the host. So once you've done that, does it make sense to run other workloads on that, or it's specifically tuned for SQL Fire and Gemfire? So we could, in theory, bring that into vCloud Director as another purpose-built provider. So it doesn't stop at gold, silver, bronze, and hardware levels. The Oracle one and the SQL Fire Gemfire could be the same hardware, same storage, same tiers of service, but tuned or purpose-built for other reasons. Right. And a single organization can utilize all those different provider tiers, and we'll talk about that in the next slide.
And that's a really good point, because how many
I kept my mind open on that one. I was like,
think about it. How many of you have within your infrastructures seen dedicated purpose-built clusters, right? We've seen licensing clusters. We've seen all these type of clusters. They're not new. This is not reinventing the wheel, right? We're talking about the fact that you have a requirement to provide X service with XYZ limitation. So you can now build this license type of clusters and provide them as a completely provided data center. That is an entire entity that's controlled by that, and you'll be ruled and validated in such way. So
now, before you carve it up, when we get into the deep dive stuff, you have to think of how you're going to carve up that provider VDC.
Right. So that's just the purpose of getting that layer, that abstraction at that point. How you're going to use that is another point we'll get into now. So just to kind of summarize on some of the stuff we talked previously here. So what basically separates these metals? The hardware, what you have available, you have offerings. Obviously, when you, in different cases, you can have, it doesn't matter to us, obviously. We're totally, the software will work on whatever piece of hardware that is compatible within our guidelines. In this case, we use an example of your offering could be differentiated by the fact that you might have a V block in one way and may have something completely different in another one. Right? That might be one of the offerings.
I just didn't have time to add the licensing one in here.
Right. So something could be in that case. It could be something that it's different hosts, like I said. Bottom line, it's up to you what you have. It's not something that is set in stone by us, by anybody. Purpose-built is about you and you serving your customers, you being able to identify exactly how you need to package that. So if we get into the provider virtual data center, there are two options that we can present as of right now.
Yeah.
Because we could probably figure something out later in 20 minutes, but we'll save it. When you're going to do your provided virtual data center, when you think about it, we basically start at the cluster level, right? We map the compute resources when it comes to the compute area because the storage is managed as a different thing, right? We add the storage later. But when we're mapping a provider data center, it maps to the compute resources of XYZ cluster. In this case, then you can obviously go from there and say either you want to have some sort of a different approach where you can take a different look at this and say, okay, I'm going to map to resource pools. If you think about what you're doing with these provider VDCs, a provider VDC and vCloud Director shows those as one type of construct. When you look underneath in the vSphere layer, what does it look like? A resource pool. See where I'm going with this? A resource pool is the mechanism of how we extract or not extract. Let's say you apply segmentation within the resource allocation of the platform, right? I'm going to take X amount percentage-wise and allocate it to XYZ customer, to XYZ provider VDC and utilize it in such a way. What happens is that once you create these allocation models, once you create these provider VDCs, you map them to one entity, right? You map them to that cluster. So everything now is going to be consumed, is going to be served from there. And in that case, you end up having one provider virtual data center. So the other option comes available when you say, okay, maybe I want to test something. Maybe I want to test having multiple provider VDCs. And that's when the resource pool comes along, right? So here, for example, if you go into a cluster within the vSphere side of the house and you start creating resource pools by default, not changing anything, when you go back and want to create a provider VDC, guess what you're going to see in the interface? You're going to see the cluster object, which is the root resource pool, and you're going to see however many resource pools are below that, right? So you can map these provider VDCs to each one of those. Now, keep in mind, it is a provider VDC. You're mapping to hardware when you map to the cluster, but when you start doing resource pool, you map into a portion of that, which if you start thinking about it, as a service provider, what are you doing? You're introducing more complexity in what you're trying to do. Right?
You already carved it up once, now you're going to carve it up again.
Multiple times.
And you're just making more work for yourself.
Right.
That's why VCAD actually recommends mapping to a cluster.
Right. I know in some cases you figure you have, we have these really large clusters, there's a lot of compute power, we want to have multiple. You can't do that, and you'll see Chris will have some scenarios that will present that to you. But one thing we want to point out here is understand exactly the pros and cons of approaching this, right? Whether you want to have starting at the higher level, in that case, think about when you have to scale, right? When you have to scale, if you add something to the cluster, if you add more storage to the cluster, if you add some sort of feature we release to the cluster, something that is beneficial to you and your offering, it's a lot easier to manage up here than it is down here, right? Weigh your options. That's the whole thing, right? Organization virtual data centers, in this case, obviously, are used to, as I said before, and you can see what I'm trying to provide here. So we have a goal provider, which is just a portion of what we have available. And yes, you can mix them, right? With the release of 5.1, you guys will start seeing a couple of new features that are now in vCloud Director 5.1, where it kind of, we promote that elasticity feature, right? So there's a lot of things you can now do which weren't available to you per se in the GUI as we have it, but you can do it, but now we just basically kind of have everything a little bit more simplified in that case. So, here's a really good consideration. And to be honest, I've been, how long have we been working with vCloud? 2 years or so, doing it in the field, many different use cases for a lot of people. Chris told me about this, and I thought it was brilliant. So I'm going to kind of let him expand on that one.
So anybody who's played with vCloud Director knows you have catalogs, right? There's catalog objects, and you place things in the catalog. Well, things in the catalog can never be powered on. So interestingly enough, they can't use compute and memory resources. But what do they use? Storage, right? They still got to live somewhere, and that storage has to be mapped to a provider VDC, because everything works off of that construct. So if we know that, and we know that all of our catalog stuff is now you've got a customer with a gigantic set of catalogs, and we're going to have all these objects in the catalog, do we want that catalog data sitting on the gold service provider? Probably not. It's going to be chewing up really expensive disk and never being powered on and never being compute and memory. So one thing we kind of came up with was this idea of create a VDC specifically for catalogs, which is similar to the bronze, right? It's a low settings. You're not going to provide a lot of CPU to it. You have to pick a CPU number, but you're never going to power anything on today. That may change, tomorrow, 20 minutes, whatever. But when you start pushing all this stuff to catalog, you know that your consumers could even have access to that same catalog VDC, right? Because your customers and your consumers can have a local catalog. So you can have a workflow or something else that actually pushes their catalog information over into this catalog VDC. It's just another thing to think about, when you're doing your designs, to say what makes sense. If it makes sense for you, great. If it doesn't, then we don't have to. Another important construct that's in VCD that a lot of people lose sight of is something called the system VDC. What makes this interesting from a resource perspective is this one does use resources. So what gets placed into this? Anybody know what gets placed into the system VDC? Except for the guys up front who work on the cloud team. The vShield edges, right? So every time you deploy now specifically, the vShield edges for an organization network, right? Not the vShield edges for a vApp network. And every time a vShield edge is deployed from vShield Manager, and I'll have to check the settings with 5.1. I apologize, we didn't do that before we put these numbers up here. But every one of those has a reservation. It has a CPU reservation and a memory reservation. So every little vShield edge has 64 megahertz of CPU and 64 megabytes of memory. Doesn't sound like a lot, but if you're a service provider with 200 org networks, do the math. It starts to add up. And those are reservations, and I'm stressing the word reservation. Everybody familiar with reservations and limits? Yeah, from vSphere, right? We all love those. Nobody uses them. Some people do. They got yourselves in trouble maybe once or twice. Well, you're going to start to see that everything in vCloud Director is based off of reservations and limits. Same with vShield edges. So when they get deployed, and you have all these things in a system VDC, the system VDC is just like a pay-as-you-go model. So it can actually flow out of its own resource pool to the cluster level. So in theory, if you deploy too many networks, you could actually chew up a lot of your cluster resources just in vShield edges. And we've got some example numbers, right? 250 vShield edges is going to yield 21 gigs of reserved memory. It's a lot, right?
How many of you, I hope everybody, or most of you, how many of you do really, really, really good capacity planning and models? Awesome.
Cool. We're going to talk to you after.
Yeah, you're going to tell me how to do it. So this plays an immense role on what you're doing here. This stuff here, what you see here, it's about capacity planning and being able to identify and understand what you need.
How many people think reservations make it easier to plan? Right? It's almost easier to do capacity planning if you know reservations are in place, because that is being carved out of physical resources. Right? It's already gone. You can't use it anymore. Right? It's harder to do capacity planning when you're not using reservations, so you're going to hopefully start to see some stuff in the next few slides. This is where it gets interesting. Not that it wasn't already. So what I'm going to take you through is each of the 3 allocation models. What I'm going to talk about is where the settings are applied, and then we're going to look at what it looks like in vSphere. So you kind of get a correlation. This is where you're going to see the terminologies change, which is where it gets really screwy. So the pay-as-you-go model the settings that you can choose from are on the left-hand side, right? So when you pull up the UI and you create a new organization VDC, this is what you pick. And Dave will notice we changed it to 1 gigahertz because we actually put the 5.1 stuff in here. Anybody remember the 0.26 default in VCD? How much fun that was, right? Oops. 260 megahertz.
Oops.
Oops, yeah. So when you set these things, the key here is to understand what you're setting, because all you see in front of you is 4 fields. And you plug in some numbers, and you hit go, and you hit next, 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 done, right? But what happened? So these are the defaults. So when we walk through this, we have a 0% CPU guarantee. That's what's used in VCD, the word guarantee. Next to it, I put the word reservation. So in your mind, use what we know in vSphere and say, that's a reservation. We have a 1 gigahertz default limit. Now I'll explain where that's applied. By default, we do 100% memory reservation. And what's interesting about this model is everything is applied at the individual virtual machine level. So once this is carved out and you deploy 25 virtual machines, every one of those 25 virtual machines, if you looked at the settings of the individual VM, will have a 1 gigahertz limited CPU. You can add as many virtual CPUs as you want, but each one will show up as 1 gigahertz. And if it was a 2x4, 2 CPU with 4 gig VM, how much memory do you think is reserved? 4, all of it, 100%, right? So 20 VMs times 4 gigs of RAM is, I don't know, my math stinks, 80 something.
I'm not there yet.
Right? That's reserved memory, not counting overhead. That's just reserved memory for the VM. Now, what's interesting about this resource pool is you'll notice it says no limits, no reservations, and expandable reservation is enabled on the resource pool. So what does that mean? That means it can flow out of its resource pool to the root resource pool, right? It can take resources from up above. So a pay-as-you-go model is what we refer to as truly all you can eat. It's all you can eat until the cluster is done, until it's full, right? So if you don't change these and you start deploying things with 100%, you're going to run out of resources really. So what happens is the higher the guarantee, lower the consolidation ratio, right? Because as you use guarantees, you lower your consolidation ratio. But this could be important to a customer. A customer could say, I want some guaranteed performance. And we can get really good guaranteed performance on a VM that's guaranteed all of its memory. But it's flat. It's across the board. So for that customer, every VM would be this way. Now, at vSphere, this is just a graphical representation, right? Whoa, that is blurry, huh? Thought I needed new glasses. That one's better?
Yeah, this one's fine.
What we're seeing is that the virtual machine memory, so in this 2 gigabytes, is pulled from the actual provider VDC because the resource pool is set to expandable reservation enabled. So it's essentially pulling it from the root resource pool, right? And it's on every VM. So every time you spin one up, it's just going to start consuming memory. So it's the opportunistic allocation is that it overflows. Now, with the next one, which is a reservation pool model, settings are applied in a different place, and the setting options are different. So you only get to pick 2 things, right? You get to pick the CPU allocation and the memory allocation. Now, you notice the terms just changed, right? Over here it was called guarantee. Over here it's called allocation, but they're both reservations. That's why we said the terms are a little wonky, right? So when you take these slides away, just keep the ones with the parentheses next to reservations, so in your minds, you know what we all know and love, which is limits and reservations. So you pick a memory allocation and a CPU allocation. What it does, it creates a resource pool exactly of that amount. So if you picked 200 gigahertz of CPU and 20 gigs of RAM, the resource pool will show 200 gigahertz and 20 gigs. It will also set the limits equal to the reservations, and more importantly, it disables expandable, right? So this is truly a box. We just put the customer in a box that they can't go above, or, they can use less, but they can't use more, okay? And the per virtual machine settings, some people don't know this, can actually be controlled by the users of the cloud, right? So they can, within their own box, say, I've got a database server, I've got a web server, I want to change the per VM settings of the database server to actually be 100% guaranteed, but the web server to not be. And when they do that, they're going to pull that out of their own resource pool, right? So the 2 gigs comes out of their box. So instead of 20, they have 16 for the rest of their virtual machines. A little bit more controlled from a provider perspective, right? It doesn't have that all-you-can-eat type of mentality. And this is just another graphical representation where once you've given them their org VDC, everything they do comes out of their own pool of resources, right? They can't flow out into the overall provider. And then the last one, which usually confuses even both of us to this day, is a hybrid. It applies settings at both the individual virtual machine level and the resource pool level. The problem is, or the challenge is, you only set it once, and you can't really you can't change what it does, right? So here's what I mean. You set what's called CPU allocation at a percentage of guarantee. Now, in this one, allocation means something completely different. The allocation is not the guarantee. You're setting a % guarantee. Everybody confused yet? Cool. That was the point. Imagine how we feel when we have to explain this to you guys. So you pick an amount of memory. You pick 20 gigs of memory. That 20 gigs of memory is the allocation. Then you pick a % guarantee of that 20 gigs, right? So you give the customer burstability space, right? So this is why we say the terms are tough to kind of follow. So we'll use that, right? So we'll say we've given this customer 20 gig, and these are the defaults, right? 10% allocation of whatever's in the, it's just an arbitrary number of what's in the cluster. And 0% by default, and guess what? Here's our 100% default again. So what happens is, if we carved out a provider VDC, an org VDC, and we gave this customer 20 gig, and we left it at 100%, their resource pool would be 20 gig of available reservation. We'll talk about what happens when we change that number in a couple slides. I'll wait for that one. Now, the interesting thing is that 100%, not this one, forget the memory one, just put that one out of your mind, but this particular 100%, or whatever that number is under memory, gets applied to each individual VM. Okay, so let's think about that. So now we've got a customer with a resource pool with 20 gigs. He's guaranteed 20 gigs because it's set to 100%, but he deploys a 2x4 VM into his resource pool. 4 gigs, the 4 gigs for that VM will all be reserved from his 20, leaving him 16. Now, I mentioned I was going to wait to change the numbers on you. Well, let's do some quick math. Let's change the 100% to 50%. Now, his 20 gigs that we gave him as his allocation only has how much available for a reservation? 10. He deploys his 2x4 VM. How much is reserved on the virtual machine? 2, because we set it at 50%. So he's going to take 2 gig out of his 10 gig, and now he's only got 8 gig of available reservation. And we'll talk about why that's important and why available reservation and overhead and things like this is key to how Cloud Director does its thing. So this is just another picture of what I was talking about, how it actually shows the burstability space. So I'm going to go through a couple slides a little quickly so we can get to the test cases. So we always talk about why HA is important. Anybody know how HA does its calculations? Slot sizing based on what? Bingo, based on reservations. Everybody see where I'm going with this? Mm-hmm. Right. But it's also the largest one, right? So if you have all of these things set at 100% or a percentage or some percentage of reservation, you think HA is kind of important to what it does in Cloud Director? Right? It's what we call the virtual bouncer in Cloud Director.
Can't get in.
Yeah, you can't get in or you can't get out. What happens is it's going to do its job when a user, so let's take any one of those, let's take the reservation pool model or the allocation pool specifically. That last example of the 50%, right? We left that customer with only 10 gig of available reservation. That's the available reservation HA admission control has to power on VMs. So every time a new one comes online or wants to come online with that 50%, it needs 2 gig of its 4 to be reserved plus overhead. But he only has 10 to start with, even though he thinks he has 20, right? Because we only set the reservation to 50% of the total. This is going to cause a lot of questions afterwards. I know it will. And we did that on purpose, right? This is really, really important. Because if we don't remember the fundamental ways that vSphere does its thing, and you start setting stuff in vCloud Director, you could have some challenges, right? So rule number 2. Rule number 1 is never disable DRS, right? Good? Everybody's covered with that? Everybody read my blog article on that one? Got me in a lot of trouble with some of the PMs. Rule number 2, don't disable HA admission control. How many people do capacity planning as a VI admin, go to power on the next VM and they get the message that says no more resources? What's the first thing you do? You go in, right-click, disable admission control, power on the VM, right? And we do that because the slot sizing is doing its thing. Anybody not use N+ in admission control? Anybody use percentage-based? right? Everybody in this room should be using percentage-based. Don't use N+. N+ uses slot size. Percentage-based doesn't. So if you have a monster VM, 32 gig VM, or now a 64 gig VM, right? Slot sizing is much more conservative. So if you actually use percentage-based and do some calculations, you'll squeeze a little bit more out of the cluster, and you'll actually you won't get in a situation where mission control is stopping your customers too soon. In pay-as-you-go, because it overflows, it takes a little bit longer for it to kick in, but it'll certainly kick in pretty quick with allocation pool, set below 50%. We got an example of what happens when you lower it even further. So really quick, this was something we put together just to illustrate that. Originally, we talked about our gold, silver, bronze, right? And that was our provider-level services that we saw as those tiers. But a good example would be we have a consumer who's they only want to pay for silver-level services, right? They don't need gold-level services, but they're willing to pay to have 100% reservation because they could actually have better performance than this customer here or this customer here where there's no reservations, right? So if they know their applications and they talk to you and they say, I've got some job applications, I've got some things that are going to need some memory reservation, can you just do it so it kind of gives it everything it needs and I don't have to muck with it? Some customers might want to screw around with it, so they might want the reservation pool so they can control it, right? That's the flexibility. We see very many service providers pick their service offerings as templates, and there's like 3 options, and that's it. What we're trying to show you is the options are unlimited if you talk to your customers.
Don't assume.
Don't assume. Talk to them. So what we're going to do is I'm going to skip to a couple slides here where we can get into the test cases because I think those are pretty interesting. You will have these slides, and these are just some review pieces. So what we did is we took use cases, yes, test cases. This is a couple slides. So we took and we built an environment, and Rawlinson and I said, well, let's put some of this to practical use and see what this means, right, when we do this. So this was our provider, right? We had 15 gigahertz of CPU, 50 gigabytes of memory. We had a vApp template that had, it was a 2x4, it was 2 CPU, 4 gigs of memory, and we're actually showing you that with that configuration, each VM also has a 250 megabyte reservation. Anybody not familiar with overhead reservations? Anybody just not willing to admit it? I actually had to remember what it was. I'll admit it. I had a nice long conversation with Frank about that.
So let me just kind of tell you a little bit on that because no one kind of claimed to know about it. It's available. It's information that's available to you in the UI in the VI client, right? You see it. You see the VM details. You can see what that is. So the overhead memory is basically the virtualization tax that it takes to produce the resources in a virtual environment for that virtual machine, specifically when it comes to memory, CPU, and other things, right? So the more CPUs you add, the more memory you add, the more expensive it becomes to support that virtual machine. Now, the fact that you didn't know about that, or maybe you just forgot, let's say you just forgot about it, it's crucial because you now, when you're doing your allocations, you have to understand that you have to calculate how much overhead is going to be applied per virtual machine so that you can allocate the right amount of capacity. Right?
vCloud Director is going to use that number right away.
vCloud Director is
vSphere
going to go right. It's going to use it right away. So it's very important. And so I don't know if but there's a white paper on that on this presentation that basically maps through that and talks about these sort of things.
Actually all of this stuff.
All of those things, because this is where sometimes we have that disconnect where we miss a couple of things that are so crucial and important. This is a platform that sits on top of vSphere. So you have to understand and know the underpinnings of on how things work down there so that you're not affected up here. And knowing these overhead things and knowing how to keep your capacity and understand how that works in your capacity planning, it's extremely crucial for your success. Right? So I want to make sure everyone knows about that.
So what we did is we took that provider and we said, let's start spinning up some consumers. So our first test was this. We created 3 customers. They were all pay-as-you-go, right? So here's the theory. I got this question from a customer. A customer called me up one day and said, Chris, I got this question. I said, what's the question? He said, VCAT says, and I'll point this out, it's being recorded. VCAT says not to mix allocation models on the same provider vDC. I said, okay. Yeah, I said, that's valid. I mean, there's a reason why we said that. And he said, well, why? I said, let me go find out. So I started making some phone calls, and I said, well, why do we make that recommendation? And everybody said, well, because we could get in a situation where stuff starts to get contentious. And I said, okay, so that's valid. So I turned around and I asked the same person I was asking a different question. I said, okay, I'm going to read into this. And I said, well, what if I use the same allocation model with different settings? I'm not going against the recommendation. And then they kind of looked at me and said, well, don't throw me that curveball. Right? It's not very much different, right? I just spun the question differently. So what we did is we did that test. We took 3 customers, and we said, okay, we're going to go by vCloud. We're going to put them all on the same pay-as-you-go cluster, right? We're going to determine that cluster is pay-as-you-go, but we're going to change all their settings. We're going to make one customer 100%, one customer 50%, one customer 0%. The 0% customer could probably get a really high consolidation ratio because the only reservations that have to be contended with for him is overhead, right? The other 2 guys are going to start getting a mixture of, and all 3 are going to have different performance characteristics, right? Because if all 3 of these customers actually throw the same application up and run tests, and let's say it's a Java app, who's going to get better performance? The guy with 100% reservation, the guy with the 50%, he's going to be somewhere in the middle, and the guy at 0, he's going to be somewhere in limbo, right? Now, what does this mean? This just means that we've got 3 customers with 3 resource pools that can overflow, and they can all utilize resources differently. How's that any different than anything we did in the past in vSphere? It's not, right? We're just letting vCloud Director set those limits and make those controls for us. And you notice we've always left CPU out. We've always been talking about memory this whole session because that's the easier one to kind of follow because that's where things run out quicker anyway. So what happens is, as these things get carved out, the demand for each customer is the same, right? Because if they all deploy the same number of 2x4 VMs, technically their demand is the same, but what they get reserved is different, right? So at some point, one customer might start swapping because he doesn't have any reserved memory. Everything he's getting is opportunistic. So then we said, all right, let's do the same thing with allocation model. So we basically set everybody to, we set 20 gig, 15 gig, and 10 gig, or this reservation pool. So we got 3 resource pools of 20, 15, and 10. This one was easy because nobody could really mess with each other, right? One customer could only spin up so many VMs. That's what happened. Now, the difference here, excuse me, I'm starting to lose my voice, is since customers can control their per VM settings, if they don't utilize that feature and they leave everything at 0, then they could get into a situation where what they're given, they could spin up a bunch of 32 gig VMs in their 10 gig resource pool, right? But where's all that memory going to be grabbed from? What's that? Somebody said it. Swap, right? They're eventually going to start swapping. Now, so in theory, could customer 3 affect customer 1? If they're on the same disk, yes. Right? This is just more things to think about. Right? It's not that this model is a bad thing. You just have to know how it all works so you can design to it. And then the allocation pool, this was the really interesting example, and this is the one I gave you where we gave 10 gig at 50%, 15 at 75%, 20 at 100%. Right? It gets really screwy when you only have 5 gigs of available reservation in a resource pool. You get like 2 VMs. Right? So HA admission control tends to kick in the fastest on that model. So then what we said is, all right, let's answer the customer's question. Let's truly do a mixed model test. Let's take a silver provider or a licensing model type of provider, right? This new idea of, I got my Oracle provider, right? It's for Oracle databases. So I got a customer who wants to do different, they want to pay differently, right? They want to pay for their databases as they spin them up versus a customer who wants guaranteed resources. They're all going to run on the same provider. Well, what we did is these are all the default settings. So we used 3 gigahertz for the CPUs. That was actually supposed to be changed to 1 gigahertz, but we did it on 1.5, so it technically was 0.26. And we basically let everything go, right? We just released the hounds and started spinning up virtual machines. Well, needless to say, it works. There's no reason it doesn't work, because it's no different than us going into Virtual Center, creating resource pools, setting these numbers on them, and spinning up virtual machines. The difference is everybody kind of performed differently, or they will perform. We didn't do performance tests, right? We didn't have the hardware to do that. But this was really more of a functional test. We want to answer the question of why. Why can't we mix allocation models? And what we ended up with an answer is, you can. Okay. And oh, by the way, that now has been updated in vCAD. Right? So the next version of vCAD is actually going to reference the 70-something page white paper on why you can do it. So we didn't want to just copy all that material in there. We said just point out to it. And then we said, well, let's do what Rawlinson and I call a true cloud, right? No defaults, because nobody should use defaults. Everything should be custom. Why? Because you talk to who?
Customers.
Thank you. All right. As long as we're going to walk around and ask people that.
Who do you talk to?
What's that?
Who do you talk to?
I talk to you.
Who do you talk to? The customer, right? That's right.
It'll be like military cadence, right? So we said, all right, let's just blow this whole thing out of the water and let's just carve this thing up no matter however we see fit. We're just going to mess around with the numbers. And this is what we decided on. We said, well, we'll do a pay-as-you-go customer at 1 gigahertz per virtual CPU. They'll be at 100% memory limit, 75%, well, that's on the resource pool, 75% reservation, and the same thing as before, right? There's no reason it didn't work. We just wanted to see what would happen if we did custom numbers as opposed to the default numbers, because we've seen a lot of people not change the defaults for some reason too. So essentially, we reduced everything from 100% to 75% from the original test, 20 gigs down to a 75% guarantee. The interesting thing about allocation pool that we'll point out is you can't set it to 0. You can't say give a customer 20 gigs of memory at 0% guarantee, because nothing will work. The lowest that number will go is 20%. What we recommend, and this, I don't know if this actually made it into VCAP, but when you start to think about that math I gave you, the 100 to the 75 to the 50, and as that goes down, two things start to come together between the guarantee on the VM and the guarantee at the pool. You reduce the pool so much that it's empty, so when you go jumping in head first, right? We tell people don't go below 50%, right? We tell our service providers that our data center, vCloud data center service providers, as part of our requirements is at 75% or higher, right? So in that model, keep that number in mind. If you want to play with it, go ahead and lower it down to 20 and see what happens. It gets kind of interesting. So we wanted to leave a couple minutes, 5 minutes for questions, because we don't like to go right to the end. Hopefully this is, you'll definitely have all the slides available. So the ones that I did skip, I promised they're just really review slides, so it wasn't as, I wanted to get to the meat of the content so we could talk about the performance implications. So if you do have questions, please use the microphones. We'll repeat the question so that everybody can hear it. Anyone, or is there?
While someone gets there, I have a question. Those of you that have vCloud Director, so far, which allocation model do you use so far? Huh?
Pay as you go?
Pay as you go.
We hear that a lot.
Okay.
Yeah.
So there's a mix, right? But I'll tell you what the majority is, as we find from the field, is pay as you go. Now let me tell you something that may or may not scare you, but maybe you should now kind of be aware of it and consider it. I think that as a service provider, pay as you go is great, right? I want you to consume as much as I have and all of it, because that's how we generate business, right? Now, if you think about how that can affect you if you don't plan that right, it's pretty bad, because now you have an open a la carte, come eat it all you want, but then did you calculate that in your capacity? Are you going to let everything be consumed 100%? There's some implications when it comes to, if a host at the lower layer, the vSphere layer we're talking about, gets to X amount of memory utilization, we have a problem. Things start swapping. How do you overcome that, right? You see that you can just basically allocate a percentage of resources, but sure. Now, how fast can you procure new hardware, new storage, and everything else, the whole stack? Think about it.
When it runs out of resources.
What's going to happen when an XYZ customer comes into punchingclouds.com, I want to get a new service, they swipe the credit card and
I
they
didn't
go...
think that's what we were going to name our service provider.
Well, I just took that name. This is mine. And they swipe the credit card and they can get what they want. Guess what they're going to say? Oh, this service provider sucks.
Or better yet, go back to the beginning of the conversation. You can't go back in and reduce a customer, right? If you've written a service level agreement for one of those services and you run out of resources, you can't
see it.
You can't go back, right, and say, well, we're going to take some away from this guy to give it to this guy if they've both signed their contracts, right? You can't play that game either. It's
going to be very expensive if you don't adhere to your SLAs. So it's just trying to connect the dots and making sure that everyone's aware. So there are a couple of things that you can do to prevent something like that. So for example, there is a little check mark in the screen where you choose pay as you go, which if you choose to take that route where you can say, I'm going to limit the amount of virtual machines that can be deployed here, but still pay as you go. You're going to get to this point, that's it. Now, the interesting part there is this. You can define a limit, or you can design your offering, what you have underneath, based on a X type of capacity model that will allow you to support X amount of workloads that you plan for, and then you know how to scale that out. Right? So that you can take that model and tie it into whatever your forecasting is, so that you'll be able to provide the service that you agreed to provide to your customers. Right? Those are some of the things that are sometimes overlooked, and we kind of like to just bring it back and say, just think about this. You know, there are implications with all types of things because everything relates to everything. vCloud Director is an abstraction of what you already have down here, and it's very important to understand how vSphere reacts to what vCloud Director wants. And so if you want to be successful, these are the kind of little things you may want to kind of be well informed on, so that you can be, you know, you can avoid any sort of missed SLAs or anything that will affect your business.
So, how many folks who've deployed vCloud Director had some of these concepts explained to you when you deployed it? By partner, PSO? Nobody? This is all new information? Not all new?
We might have spun it differently.
We might have spun it differently. Somewhat new?
Well, here's what happens too, you know. Sometimes things get developed to serve a certain purpose, but then little did you know they serve other purposes as well, right? We started on a track with cloud. We wanted to do this. We have these allocation models. We want to do this. But you also have the capability of providing something else that is not, it wasn't natively designed to be done with this tool in the way we do it, right? Chris' example of using the licensing cluster, that's one. You may also have a requirement where this model moves towards multi-tenancy and being able to share everything across, right? But what if you have to adhere to some sort of security, some compliance issue where I need to have my own hardware? I can't really share this with anybody else. You can still do that, right? It's when you create another purpose-built cluster and you say, I'm going to create this provider VDC for this particular customer, and guess what goes in there? You can dedicate it, right? So these are the different ways you kind of got to start thinking about and continue to be flexible, because as the products and the platforms continue to change and emerge and more things become available, down in the vSphere layer, they're reflected up here as well. How many of you know now that some of the things that were released on Monday are now part of vCloud 5.1? For example, storage, right? Now you have some of our storage cluster features from vSphere are now supported in 5.1.
Forget the new networking stuff.
Right? VXLAN, right? Now you have, and here's another one in terms of making your calculations correctly. We talked about vShield, right? vShield now within your configuration has a feature that now gives you high availability. You know what that means? I'm going to deploy another appliance. Remember what he said about what's reserved and what's not? And now
two of them.
Two of them, right? And how many places you're going to do that? Now, it brings back the question, do we need DR? What's the service level? What are we doing? So these are the sort of things that you have to kind of understand and somewhat remain flexible about, because you'll run into them here and there. We want to obviously make sure that people are, everyone's successful and kind of are aware of some of these little things that make a really big impact on what you're doing. Any questions, please?
Can you change allocation models? No. Once you've picked an allocation model and created, think of it this way: you've built your provider VDC, you've built your data center. You can migrate workloads from one allocation model an allocation model is a provider VDC, right? Just think about it that way. Well, you can move workloads. You have to shut them down and move them today, right? Because you could potentially be moving them to different hosts. You could be moving them to different storage. So the process of the move is very simple. You can do it through the APIs. You can do it through the UI. So if you do make a mistake, you can edit the settings of an existing virtual data center, right? So if that customer who paid for 20 gig in a reservation pool wants 40 gig, you can go in and bump it up, right? The pay-as-you-go is a little different, because if you gave them a 1 gigahertz CPU and they want a 2 gigahertz CPU, you can make the change. But for any deployed virtual machines, they've just got to be power cycled. So then vCloud Director will reapply the new limit, essentially. I actually had a provider do that for me, because I realized I knew I was in like a 1 gigahertz environment, and I said I want 2.5. So I fought them to have it changed. So yeah, you have to consider that though, right? So once a customer purchases one VDC of one type, you can move them, but there could be downtime involved. Good question though. We actually get that question a lot. Yeah. We're probably going to get kicked out in a minute, but. Yes. So the question is, doesn't pay-as-you-go come with some performance implications? It could, right? So that's why the 0.26 default was so horrible, because it basically set a 260 megahertz limit on all the CPUs. So when you deployed a Windows VM with 32 gigs of RAM and 260 megahertz of CPU, it took a really long time for that thing to boot up. Well, yes, it is a top-out limit, right? So you have to think, based on your host, what is the appropriate CPU speed? And it's basically giving the customer a box with a CPU speed assigned to it. So if your hosts support 2.6 or 2.3, some providers will kind of use something a little lower. They'll say 2 gigahertz or 2.1. They'll reserve some of that for themselves. So for customers to get additional speed out of that, they've got to add other virtual CPUs, right? So if they have a multi-threaded application that needs more performance, you can scale out the CPUs, but you can't go into a VM and say this one VM is unlimited on its CPU. It is a limit.
And also another thing is, how we obviously have an issue with the 2.6 deal, but it's been changed to 1 gigahertz. So just to kind of dig a little deeper in that, if you were to have a completely vetted out and understanding of your workloads and what you're going to have in your cloud, and you can understand the demand that's going to be put out there on the regular and what's normalized, if you within your capacity planning have a definition of the allocation, of the unit of allocation, you can actually drive that and be even more effective. Where maybe 1 gigahertz is too much, you have what you need, but maybe the application doesn't really behave that way. You still have the control and the capability to add, to configure the megahertz with enough frames so that it can go up or down, but you can, it doesn't have to be too much so the resources are not misutilized in one.
We can talk more after.
We can talk, yeah.
Because they're going to boot us out of here.
Okay. Well,
thanks, everybody.
Thank you.
Enjoy the party tonight.